Students, today we are going to continue the lesson of atomic structure. The next subtopic is valency. In the previous class I told that protons and neutrons, see in this figure itself, protons and neutrons, that blue and green color, they are the protons and the neutrons. These are found always in the center of an atom, and that where these protons and neutrons are found are in the nucleus. So these protons and neutrons, when they are found in the center, and it will be around this are the electrons, which will be always orbiting around this protons and neutrons. Okay, so electrons are revolving around the nucleus in a circular path called as orbits or the cells. An atom has a number of orbits, and each orbit has electrons. See, this is an atom shown in the diagram. In that, see the orbit, the reddish color like beads, they are the electrons. So in the center is the nucleus, and inside the nucleus is the protons and the neutrons. Yellow color and blue color are the protons and the neutrons, and around it the electrons are orbiting, that means revolving around. Okay, and there are many orbits, 3 orbits they have shown, and in each orbit there are different electrons. Okay, the electrons revolving in the outermost orbit are called as the valency electrons. So the orbit, that bluish color orbit, the last ring is called as the orbit. On that is called, and on that ring or in that orbit, how many electrons are that? They are called as the valency electrons. Okay, understood what is valency, what are protons and neutrons, where it is found, and what are the orbits, where are the electrons, and what are the valency electrons. Next is the electronic configuration. The arrangement of electrons in the orbit is known as electronic configuration. So how these electrons are arranged in these orbits? Orbits are the ring-like structures. On this, how these electrons are arranged, they are called as the electronic configuration. Okay, so atoms of all the elements will tend to have a stable electronic configuration. So each atom will be having a fixed electronic configuration. Okay, and they will tend to have either 2 electrons. They will be known as the duplet. Sometimes they will be having a stable electronic configuration. Stable thing will be, if I take an hydrogen atom, there will be a stable electronic configuration for that hydrogen. Okay, it will be always stable for all. How much hydrogen atoms you are taking, all will be having the same electronic configuration. Okay, they have either 2 electrons or known as duplet, or 8 electrons in their outer orbit or the electronic configuration. Outermost orbit, they will be having 8 electrons or 2. 2 it is called as duplet, and if it is 8 it is called as a octet. For example, helium has 2 electrons in the outermost orbit. So helium, how many electrons it is having? Always it will be having only 2 electrons. So it is called as duplet, and chemically it is inert. Neon is chemically inert because it has 8 electrons in the outermost orbit. The valence electrons in an atom readily participate in a chemical reaction, and so chemical properties of an element are determined by these electrons. When molecules are formed, atoms combine together in a fixed proportion because each atom has different combining capacity. So this combining capacity of an electron of an atom is called a valency. So valency is what? The combining capacity of an atom. So when molecules are formed, atoms combine together in a fixed proportion, and this combination is called as valency. Or in other words, we can say as valency is defined as the number of electrons lost or gained shared by an atom in a chemical combination is called as valency. So that is a definition. We can say in the simple words, combining capacity of an atom is called as valency, or how many electrons it gained or lost in a chemical combination is called as valency. Okay, then types of valency. There are different types of valencies. What are the different types of valencies? In order to understand valency in a better way, it can be explained in 2 ways depending on whether an atom gains or loses electrons. We told valency means gaining or losing of electrons. So atoms of all metals will have 1 to 3 electrons in the outermost orbit. In the outermost orbit, all the metals will be having 1 electron or 3 electrons. By losing these electrons, they will have stable electronic configuration. When they are losing it, they will be having a stable electronic zone. So they lose them to other atoms in a chemical reaction and becomes positively charged. They will lose these electrons and becomes positively charged. Such atoms which donate electrons are said to have positive valency. Those gives away, those donates the electrons, they are called as the positive valencies. Okay, so to positive. For example, sodium atom atomic number is 11, has one electron in its outermost orbit, and in order to have stability it loses one electron and becomes positively charged. Sodium always it is positively charged because it is having only one electron in its last orbit, and that electron it will donate it off and it will become positively charged. The sodium has a positive valency. Always it is sodium will be having a positive valency. The atomic number is 11. In that the one electron will be in the last orbit will be donated and it will get a positive charge. All non-metals will have 3 to 7 electrons. All the non-metals will be having 3 to 7 electrons in the outermost orbit of their atoms. So non-metals will be having how many electrons? 3 to 7 electrons. And the metals will be having how much? 1 to 3 electrons, okay, in their outermost orbit. So in the non-metals, 3 to 7 electrons in the outermost orbit of their atoms. In order to attain the stable electronic configuration, they need few electrons. They need some more electrons. They accept these electrons from other atoms in a chemical reaction and becomes negative charge. When they are accepting, when they are gaining the electrons, it will become negative charge. So non-metals are always negatively charged and the metals are always positively charged. In the non-metals, they are having 3 to 7 electrons in their outermost orbit. In the metals, they are having 1 or 3 electrons in their outermost orbits. So non-metals always they gain the electrons, so they are getting negatively charged. Metals are always losing the electrons, so they are getting positively charged. Those who are gaining always negative, those who are losing they are positive. Always remember in that way. These atoms which accept the electrons are said to have negative valency. So let us underline that also. So they are accepting it, so they are having the negative valency. For example, chlorine atom atomic number is 17, has 7 electrons in its outermost orbit. By gaining 1 electron, it attains stable electronic configuration. To get the stable electronic configuration, it should be 8. 8 or how much? It should be 8 or 2. 2 means duplet, 8 means octet. So if when it gets 1 more electrons, it will get 8. So it will get a stable configuration. Like inert gas electronic configuration, thus chlorine has negative valence. So chlorine is always having a negative valency. Understood? Metals and non-metals. Now valency with respect to atoms. Valency of an element is also determined with respect to other atoms. Generally, valency of an atom is determined with respect to hydrogen, oxygen and chlorine. Generally, it is found on the basis of these three: hydrogen, oxygen and chlorine. Now valency with respect to hydrogen. How we can understand the valency with respect to the or determine with respect to hydrogen, oxygen and chlorine. All the three we have to learn. Now first with the valency with the hydrogen. Since hydrogen has atom loses one electron in its outermost orbit, its valency is taken as 1 and it is selected as the standard. Always hydrogen is having one electron and it will lose an electron and it will get standard. Valencies of the other elements are expressed in terms of hydrogen. Thus, valency of an element can be also be defined as the number of hydrogen atom which combine with one atom of it. In hydrogen chloride molecule, one hydrogen atom combines with one chlorine atom. The valency of chlorine is 1. Similarly, in water molecule, 2 hydrogen atoms combine with one oxygen atom, so the valency of oxygen is 2. So understand what it is. So when hydrogen is having only one valency and that hydrogen combines with the chlorine and get valency chlorine is 1. So hydrogen atom combines with one chlorine atom, thus the valency of fluorine is 1. And in water, hydrogen combines with 2 oxygen atom, so the valency of oxygen is 2. That means always the valencies are calculated on the basis of hydrogen, oxygen and chlorine. For hydrogen, since the chlorine gets combined with hydrogen with one valency with one hydrogen atom, so it is having the chlorine will be having one valency. In water, oxygen combines with 2 hydrogen, so its valency of the oxygen becomes 2. Understood? H2O. So one oxygen combines with 2 hydrogen atoms, so the valency of oxygen becomes 2. In HCl, hydrochloric acid, chlorine combines with 1 hydrogen atom, so the valency of chlorine becomes 1. Understood? Okay, so I think you understood. So when a valency of an electron, when an element of chlorine combines with 1 hydrogen, so the valency of chlorine becomes 1. Okay, and when 2 hydrogen combines with oxygen, so the valency in water, so the valency of oxygen becomes 2. Okay, so this is the valencies with respect to hydrogen atoms. Since some of the elements do not combine with hydrogen, so some other elements never they combine with the hydrogen atom. The valency of the element is also defined in terms of other elements like chlorine or oxygen. So those elements which are not combining with the hydrogen, they has a temptation to combine with chlorine or oxygen. So on their basis, we say the valency for the other elements. This is because almost all the elements combine with chlorine and oxygen. Those who are not combining with hydrogen, most probably they combine with chlorine and oxygen. Most of the elements always have the tendency of combining with chlorine and oxygen, so their valency will be determined on the basis of chlorine and oxygen. Okay, now next we are going with the valencies with the respect to chlorine. Okay, see here they have shown hydrogen in the tabular column. Hydrogen chloride, chlorine combines with 1 hydrogen, so its valency is 1. Water, 2 hydrogen atoms, so the oxygen valency is 2. Ammonia, it combines with 3 hydrogen atoms, so the nitrogen valency is 3. Methane, it combines with carbon combines with 4 hydrogen atoms, so its valency is 4. So where all the hydrogen is numbered, that will be the valency of these all elements. Hydrogen chloride 1, in that chlorine's valency is 1. In water, the valency of oxygen is 2. Ammonia, the valency of hydrogen is 3. And in methane, the valency of carbon is 4. Understood? Now next elements with the how to calculate the valency with respect to chlorine. Valency of chlorine is 1. The number of chlorine atoms with which one atom of an element can combine is called its valency. In sodium chloride, see there only one chlorine is there, isn't it? NaCl molecule, one chlorine atom combines with one sodium atom, so the valency of sodium is 1. Sodium always combines with chlorine only, so it is combining with one chlorine atom, so it has the valency, sodium will be having the valency 1. So the valency of sodium is 1, but the magnesium chloride MgCl2, so how many chlorine atoms are there? 2. So so magnesium will be having the valency 2. Valency of magnesium is 2 because it combines with 2 chlorine atoms. Okay, understood? So how it is? So for this all you need to learn the chemical formula. Now next is valency with respect to oxygen. In another way, valency can be defined as a double the number of oxygen atoms with which one atom of an element can combine, because valency of oxygen is 2. Always the valency of oxygen is 2. So it can combine with 2, double. For example, magnesium oxide MgO, valency of magnesium is 2. Whenever the valency of oxygen is always 2, so in what all elements it go and combines, always it will be the valency will be 2. Magnesium oxide MgO only is written, but always oxygen is having the valency 2. It will be having the magnesium will be having the valency 2. Okay. So now comes the variable valency. In this variable means different. Okay, different types. Atoms of some elements combine with atoms of other elements and form more than one product. Some atoms will combine with other atoms and more products will be formed. They are said to have different combining capacity. The combining capacity also will be different. These atoms have more than one valency, so their atoms will be having different valencies also. Okay. For example, copper combines with oxygen and forms two products, namely cuprous oxide Cu2O and cupric oxide CuO. In cupric oxide, valency of copper is 1, and in cuprous oxide, the valency of copper is 2. So in cupric oxide, copper combines with oxygen and forms two products, namely cuprous oxide. One is cuprous oxide and one is cupric oxide. In cuprous oxide, the valency of copper is 2, Cu2O. Okay, so valency will be 2. In cuprous oxide, valency of copper is 1, and in cupric oxide, the valency of copper is 2. Why? CuO. Always the valency of oxygen is 2, we told. How will we told in magnesium oxide? So it will be 2. And in cuprous oxide, Cu2O. So there the Cu2O, it will be 2 copper. Valence will be 2. For the lower valency of suffix and prefix is there. Suffix means backside, prefix means front side, is attached to the end of the name of the metal. For example, valency of suffix IC is attached to the end of the name of the metal. Sometimes Roman numerals such as 1, 2 and 3, 4 etc. indicated as the parenthesis followed by the name of the metal can also be used. So with the suffix what in the IC, what is the suffix in the IC, it is coming with that, what it is coming, that will be the valency. Okay, and for the Roman letters also will be 1, 2, 3 and 4 will be also indicated as the parenthesis followed by the name of the metal. So these are the variable valencies. So we have studied the hydrogen valencies with hydrogen, valencies with oxygen, valencies with chlorine. Okay, in hydrogen it will be always 1 the valency, the metals which are joining with that, combining with that, and with oxygen it will be 2, and with chlorine again it will be 1. And if the suffix IC is coming, what is the number joined, that will be the valency, or the Roman letters what will be added with the name of that element, that will be the valencies. Okay, I think you must have understood what is valency, what are the different types of valencies. Next class we'll go for the ions. Thank you, students.